Hi everyone. So today I'm going to present my work in mid-unit assignment. Okay, let's see question 1. Determine the trigonometric equation that models this information. Here the y-axis represent the temperature in degrees Celsius, and the x represent the month. Here I found the highest point and the lowest point to determine the midline, the position of the midline. I did a red line here. Then it's the midline is 21 minus 24 and divide by 2. It's y equals to minus 1.5. And the amplitude, it's just the highest point minus the position of the midline, which I can get the distance between these two spots. That's the amplitude. And the amplitude is 22.5. So that's the A value. And now we need to, oh, by the way, the midline is the H value. So I picked the cos function for this question. And y equals to 22.5 cosine and b times x minus 7. This 7 here, it's the highest point here. 7 represents July. So it starts from the top to the bottom. Okay, so I just need another point to find the b value. So I pick 510 here. It's the value for May, and I found that the b equals to minus 0.517. So now I have the whole equation for this question. So move on to question 2. A Ferris wheel has a diameter of 10 meters and takes 24 seconds to make one revolution. So 24, it's the period, and so the good thing is for this question we have the period. So sketch a graph to show. Okay, so that's the graph I did here. The highest point is at 11 and the lowest point is at 1. And write a trigonometric equation that describes the graph. So from this graph, we can find several things. At first, the midline is at y equals to 6. And the period, like I said, is 24. So we can find the k value by dividing the 2 pi by 24. So the k equals to pi over 12. And the amplitude as well equals to 5. Now we have all the values. The h equals to positive 6. It's the value of the midline. So now that's the complete equation. Question C. Check the accuracy of your equation by using t equals to 12. So with this step, I can confirm that this equation is good, because when t equals to 12, it gives me really the highest point for this equation. So the highest point is 11. But for confirm more, I did 2 other calculation. I picked when t equals to 6 and t equals to 18. Would that give me the same value for y equals to 6? Yes, it did. So now I can say this is the good equation for this question. And let's see question 3. question 3, the height of the tide in the Bay of Fundy relative to a pier varies from low of 4.5 meters to a height of 17.3 meters. So at first we can see the time here is not with the point we used to see. So we need to convert those times to the times we are more familiar with. So like I did, but here the 821, I can convert it to 8.35 hours. So with those numbers, we are more familiar to do the calculations. So question A is to find the equation. Like always, we find the amplitude by dividing or by subtracting the highest point and the lowest point, then divide by 2 is 6.4 for the amplitude A value, and the midline is 10.9. That's the H value. So how do I find the period? So here I did, because it takes 6.22 hours for the tide from the lowest point to the highest point. Then it will take the same time for it to go from the highest point to the lowest point. So we need to double this number. So it's 12.44 for the whole period. So with that, we can find the K value, which is 50 pi over 311. So that's the K value. And we just pick any point we just pick a point for the B value. Oh no, not B, for the C value. So here I picked the minus 8.35 because it's more familiar to me because it's from the top to the bottom. Then I don't need to put a minus sign before. So now I got the whole equation here. Then let's move on to question C. Question C. Determine the height of the tide relative to the pier at 11:30. So at first, like always, I convert 11:30 to 11.5 hours. So I plug 11.5 into this equation, then I got 10.8. That's the height of the tide at 11:30. Then let's see question D. A boat needs a depth of at least 12 meters to dock at the pier. So use a graphical approach to determine when the boat is able to dock and when it must leave. So in this question, we need to find the interval of time for the boat. Here I just did when h equals to 12, what the t will be. So it gave me 11.12, but it's not enough. It's just one point here. I need to find the point before it. So I just took the middle point here, the highest point, minus this distance here, because this distance is equals to this distance here. So I just make that highest point minus this part, so it will give me the point here. So now we have 5.58 and 11.12 for these 2 points. but it has two other points further. So we just need to add the period to those points. So for this interval is from 558 to 11.12. It's right here. And for those 2 points is from 18.02 to 23.56. So there are two intervals, and we convert back those times to regular hours. So it's from the dock, the boat must dock at 5:35 and must leave by 11:07. Then the second interval says that the boat again needs to dock at 18:1 and must leave by 23:34. So that's the whole assignment. Thank you.